Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farhanah from Libasmat, and today I'm going to present about polymer. What is polymer? Polymer, defined as long-chain molecules made from a combination of many repeating basic units of monomers that join together through a polymerization reaction. Source of polymer. Polymers can be classified according to source, characteristic, and polymerization process. Source, from which they are obtained, either natural materials or synthetic material. Characteristic of thermoplastics, thermosets or elastomers. And lastly, polymerization process, either by addition or condensation reaction. Natural polymers. Natural polymers exist naturally, normally from living organisms. The table shows example of natural polymer and its monomer. Synthetic polymers. Synthetic polymers are man-made polymers produced from polymerization reactions in the laboratory or industry. Monomers are usually obtained from petroleum fractions. Table shows example of synthetic polymers, their monomers, and their main uses. There are three types of polymers: thermoplastic polymers, thermosetting polymers, and elastomer polymers. Thermoplastic polymers. Polymers that become soft and thus moldable when heated and hard when cooked. Process of softening and hardening can be repeated over and over again. The second one is thermosetting polymers. Polymers that once set cannot be softened by heating, cannot be reversed once the polymer has hardened. Cross-links between the polymers chains prevent the polymers chains from moving apart when heated. Thermosetting polymers include bakelite, vulcanized rubber, and melamine. When heated strongly, the polymer decomposes. Elastomer polymers. An elastomer is a polymer that can be stretched when a force is applied to it. It returns to its original shape or length when the force is released. Elastomer polymers have elasticity properties. A few crosslinks are present between the polymer chains. The chains will slide over one another and the polymer will not return to its original state. And the last one, polymerization reaction. Addition polymerization. Addition polymerization occurs when monomers or their derivatives that have double covalent bonds between two carbon atoms react with one another. Produces polymers that consist of only one type of monomer. The polymers are called homopolymers. Some examples of addition polymers are polyethylene, polypropylene, polychloroethylene, and perspex. The second one is condensation polymerization. During condensation polymerization, other products are formed and eliminated, such as water or hydrogen chloride. Condensation polymerization consists of at least two different monomers. The polymer formed is called a copolymer. Nylon is a synthetic polymer known as polyamide. It is produced from two different monomers, which are a carboxylic acid and an amine. Natural rubber. Rubber and history. Rubber is described as materials which show elastic properties. Rubber trees or Hevea brasiliensis was introduced to Malaysia in 1877. Natural rubber is widely used in our country as it is a vital agriculture product or commodity which is used in the manufacture of a wide range of products. Natural rubber is a natural polymer called polyisoprene. Natural rubber is an elastomer as it is elastic. Its monomer is an isoprene or 2-methyl-1,3-diene in IUPAC nomenclature. The isoprene molecules undergo addition polymerization to produce polyisoprene. The elasticity of natural rubber enables it to be used in tires, engineering components, balloons, medical tubes, and elastic thread. Rubber is an excellent material to make surgical gloves because natural rubber is a natural polymer which is a covalent compound. Covalent compounds do not dissolve in water, hence body fluids and the blood cannot penetrate the gloves and infect the user. Coagulation of latex. Latex is a white colloidal solution like milk containing rubber particles covered with negatively charged protein membranes. The negative charge on the surface of the rubber particles repel one another and thus prevent the particles from combining and coagulating. That is why latex remains in liquid state. By adding acids such as methanoic acid or ethanoic acid, latex can be coagulated. Whereas by adding alkalis such as ammonia solution, latex remains as a liquid. Therefore, the acids are known as coagulants and the alkalis are known as anticoagulant for latex. Process of latex coagulation. When acid is added to latex, hydrogen ion from the acid neutralizes the negative charge on the protein membranes of the rubber particles. The rubber particles no longer repel each other and can collide with one another. As a result, the rubber particles coagulate, or we can say the latex coagulates. The activity of bacteria in the air produces an organic acid called lactic acid. Hence, hydrogen ions from the lactic acid neutralize the negative charges on the protein membrane of the rubber particles. As a result, coagulation of latex still occurs when latex is left for a few days. Latex coagulation prevention. When an alkali is added to latex, hydroxide ions from the alkali neutralize the hydrogen ions in the acid produced by bacteria. As a result, the negative charges remain on the surface of the protein membranes and the rubber particles keep on repelling each other. Thus, the coagulation of latex can be prevented by adding an alkali. Vulcanization of rubber. Natural rubber is soft and easily oxidized when exposed to the air for a long time. Vulcanization is a process to improve the characteristic of natural rubber through the production of crosslinks between polymer chains. Natural rubber can be hardened by heating it with sulfur, adding metal oxides or peroxides, immersing it in the sulfur dichloride solution in methylbenzene, or irradiation with gamma ray. In the process, sulfur atoms react with the double bonds in natural rubber molecules to form crosslinks between the long polymer chain CSSC. If a rubber strip is stretched, the sulfur crosslinks will prevent the rubber molecules from sliding over each other. As a result, vulcanized rubber is more elastic than natural rubber. Properties of vulcanized rubber. So if you guys can see, the vulcanized rubber is more elastic than unvulcanized rubber, harder than unvulcanized rubber, and the strength is more stronger than unvulcanized rubber. And now the last subtopic, 4.3, synthetic rubber. Synthetic rubber is a synthetic polymer that is elastic in nature or elastomer polymer. Created in 1909 by Fritz Hoffmann, it has a similar structure to natural rubber and is cheaper than natural rubber. Solid synthetic rubber is flexible, durable, hardens when cooled and can be molded and heated. It is also resistant to heat, light, and is used as an electrical insulator. Depending on the chemicals added and the properties associated with it, synthetic rubber can be as hard as a boiling ball, or as elastic as a rubber band, or as soft as a sponge. There are many types of synthetic rubber. Approximately 70% of all rubbers used today are synthetic rubber. Uses of synthetic rubber. There are about 20 different types of chemicals used for making different synthetic rubbers. Some of the popular synthetic rubbers are polychloroprene, chloroprene rubber, neoprene, silicone rubber, styrene butadiene rubber, isoprene rubber, butadiene rubber, and many more. Different types of synthetic rubber have their own characteristics and use. And these are characteristics of synthetic rubber: elastic, hard, resistant to heat, resistant to chemicals, resistant to oxidation, and lastly, heat insulator. The table shows examples of synthetic rubber and their uses. Use of rubber and the environment. Firstly, natural rubber. Uses and effects. Natural rubber is divided into vulcanized rubber and unvulcanized rubber. Unvulcanized rubber has few uses. It is used in cements, adhesive compounds, insulating, and friction tips. Vulcanized rubber has many uses. It is abrasion resistant. This type of rubber is suitable to make vehicle tires and conveyor belts. Tires made from natural rubber are better than tires made from synthetic rubber. This is because natural rubber doesn't get heated up fast. This is especially stable for making aircraft tires. And the last one, synthetic rubber, uses and effects. Research on natural rubber is being conducted to produce synthetic rubber polymers that can replace the use of metals and even replace organs in our bodies, as well as for other applications. Soot is of the worst effects from the production of synthetic rubber. During vulcanization of synthetic rubber, soot is produced. Soot consists of carbon particles that contribute to environmental problems. However, synthetic rubber, like some brands of neoprene, can be recycled to make shoes or t-shirts. That's all from me. Thank you.